Hello everyone, myself Bhumika. I'm here to discuss a topic on more complex SQL retrieval queries. Introduction to more complex SQL retrieval queries. More complex SQL retrieval queries involves advanced technologies for fetching the specific data from a database. These queries are essential for extracting the insights and generating the reports from the large data sets. Mastering complex SQL queries can enhance the efficiency and effectiveness of the database operations. Subqueries in SQL. Subqueries in SQL are nested queries that provide a way to access data from the multiple tables in a single query. Subqueries can be used to select, insert, update, and delete the statements. They are useful for filtering, sorting, and aggregating the data in a flexible manner. Common table expressions. CTEs allows for defining temporary result sets that can be referred within a query that enhance readability and maintainability of the SQL queries by breaking them into the logical parts. CTEs are particularly useful for the recursive queries and the complex data transformations. Window functions. Window functions in SQL provide a way to perform the calculations across a set of rows related to the current row. They can be used to calculate the running totals, ranks, and averages within a specified window of data. Window functions are powerful tools for analytical queries and reporting the windows. So there are different types of window functions: aggregate, ranking, and values. In aggregate, we have average, maximum, minimum, sub, and count. In ranking, row, number, rank, dense, rank, perfect rank, entile, value, lag, lead, first value, last value, nth value. Pivot tables. Pivot tables in the SQL allow for transforming the rows into the columns to present the data in a more structured format. They are helpful for summarizing and aggregating the data based on the specific criteria. Pivot tables can simplify the complex reporting requirements and improve the data visualization. Advanced joins. Advanced join techniques such as the outer joins, cross joins, and self joins help retrieve data from the multiple tables based on specified conditions. Understanding when to use each type of join is crucial for constructing the complex SQL queries. Advanced joins enables the combination of data from the different sources to extract the meaningful insights. Union and union all operators. The union operators combines the results of the two or more select statements into a single result set while removing the duplicate rows. The union all operator does the same but retains all the rows including the duplicates. These operators are useful for merging the data, for multiplying, for multiple queries into an undefined data set. Indexing and performing optimization. Proper indexing of tables can significantly improve the performance of the complex SQL queries. Indexes help speed up the retrieval operations by facilitating the quick access to the specific rows. Understanding indexing strategies and the query optimization techniques is essential for enhancing database performance. Handling the null values. Dealing with the null values in the SQL queries requires careful considerations to avoid unexpected results. Functions like the colasec and is null can be used to handle the null values in the expressions and comparisons. Properly managing the null values is crucial for accurate data analysis and reporting. Optimizing query execution plans. Understanding the query execution plans generated by the database optimizer can help optimize complex SQL queries. Analyzing execution plans can identify the potential bottlenecks and suggest a way to improve the query performance. Optimizing the query execution plans involve fine-tuning indexes, rewriting queries, and using the appropriate joint strategies. Data normalization and denormalization. Data normalization is the process of analyzing the data in the database to minimize the redundancy and the dependency. Denormalization involves reintroducing the redundancy for performance optimization in the red-heavy scenarios. Choosing between normalization and denormalization depends on the specific requirement, the database, and the query overload workload. Advanced filtering techniques. Advanced filtering techniques in SQL, such as the using the having clause and the subqueries, allow for filtering aggregated data. These techniques enable the application of conditions marked grouped data for after aggregation. Understanding how to use advanced filtering techniques can refine the queries results and extract specific insights. Working with JSON data. SQL database supports querying and manipulating the JSON data, allowing for flexibility and dynamic data storage. Functions like the JSON underscore value and JSON underscore query enables extracting specific values from the JSON documents. Working with the JSON data in the SQL queries can facilitate handling the complex and semi-structured data formats. Handling the hierarchical data. Hierarchical data structures like organizational charts can be represented and queried using the common table expressions. Recursive CTEs enables traversing hierarchical data and performing the operations like the tree traversals and the path enumeration. Handling hierarchical data in the SQL queries requires understanding recursive query techniques. Data aggregation and analysis. SQL provides powerful aggregation functions like sum, average, count, and group by the performing analytes on the database. Window functions and advanced aggregation techniques can help derive insights from the data sets efficiently. Data aggregation and analytics play a crucial role in the decision making and business intelligence applications. Implementing security measures. Implementing security measures like the role-based access control and data encryption is essential for safeguarding sensitive data in the SQL database. SQL injection attacks can be prevented by using the parameterized queries and input validation techniques. Ensuring that data privacy and integrity is a paramount when dealing with the complex SQL queries and sensitive information. Error handling and transactions. Proper error handling mechanisms such as the try-catch blocks help manage the exceptions and errors in the SQL queries. Transactions ensure the automaticity, consistency, isolation, and durability properties of the database operations. Implementing error handling and transaction management is crucial for maintaining the data integrity and reliability. We come to the conclusion of this topic. More complex SQL retrieval queries offers advanced capabilities for extracting database and analyzing the data from the databases. Mastering these techniques can enhance the efficiency and effectiveness of the database operations and reporting tasks. Continuous learning and practice are key to become the proficient in working and optimizing the complex SQL queries. I hope this presentation helps in understanding.